So today we're going to talk about introduction to Unreal Engine, but I want to get some administrative stuff out of the way. So I want to point out that assignment 1 is going to be due tonight, midnight. So make sure that you guys get that done in time and be aware of where you'll get deductions on that. Just look over this before you submit to make sure that you hit absolutely everything that I require for assignment 1. And then assignment 2, you should be able to start this afternoon and get that turned in, but it's not due till the 6th, which is on Sunday. So you could totally get that done tonight, or you can wait for the weekend. And then don't forget your submission or your discussion post on pseudocode. You can post that at any time, any point in time between now and September 13th. Just don't forget you got to do a post and a reply. So you want to make sure you get both of those. And then we'll get into assignment 3 and assignment 4 next lecture. Okay, so you guys should have been exposed to how to navigate around Unreal, what everything looks like through those badges that you got from the end of DES 1, or for those of you who had supposed to have PGF2 this month, you should have done the prerequisites that in the folder on the base of the folder on the drive. All right, so what are we going to be covering today? So it's basically blueprint editor layout. So what does it look like? How to navigate around it, how to add stuff, as well as we're going to look at what nodes are, what wires are, what pins are, how to add variables, what variables can do, getters and setters for those. And we'll do some math and logical operators, and then we'll talk about functions, events, and macros, and the difference between the three, as well as how to add each one and stuff like that. So very exciting day. So let's start with the blueprint editor overview. So the most important thing on the editor is number 1, which is your toolbar up at the top. You should be familiar with some of this stuff from the video. Your compile button, just basically make sure that all your nodes are able to execute properly. Save button, we're gonna pretty self-explanatory. Browse, which is your find in blueprints, so that you can search your blueprints. I'm sorry, that's browse the content browser. And then find is the find in blueprints, where you can search throughout your blueprint, as well as blueprints throughout the project. And I'll show you that today as well. Class settings, this is things like what class is my parent class, and do I have any interfaces associated with this blueprint? You'll learn about interfaces later on, but the most important thing is parent class in the class settings. Class defaults are for your default variables, values, as well as some other things, some important stuff in there. Simulation and play are kind of similar. Simulation just runs like physics, it runs effects. So you can simulate some things, but most of the time you just want to use the play button to test out your work. And then the most important thing up here is your debug filter, and I will talk about that later on. All right, so number 2 is our components panel. So this is where we're adding components. We can also remove components from here. You just hit this big green add component button, and then you search through the drop-down list for the components, or you can use this, once you add the component, there will be a search bar in there that you can use to find the specific component you want. This search bar up here is referring to searching through your component list. So if it goes beyond what you can see in the panel, you can just use that to search through this list right here. Number 3 is the second most important part of the blueprint. It is the My Blueprint panel, or My Blueprint tab. And this is where you're going to add your events, your functions, your macros, your variables, event dispatchers. And if you go into a function, you'll get a category for local variables. At any point in time, you can add stuff to this. You can even create new graphs if you wanted to. And then basically all these plus symbols we'll add something in that category. So the plus symbol next to the functions, we'll add a function. Plus symbol next to the macro, we'll add a macro, and the variables, and so on and so forth. The third most important part of the blueprint is your details panel. It's where you're going to be setting your values for things like your location in the viewport, as well as things like camera settings or anything related to your components or your variables. You'll be able to adjust those values. And there will be a lot of information in here that you won't be using on a day-to-day basis, but it is important to be aware that depending on what you select over here, determines what's populated over here. You should be familiar with that from like Unity. Unity, very similar. Number 5 is your viewport. It's where you're going to add, well, it's where you're going to adjust some settings. So things like which direction is your character rotating to and facing, adjusting the capsule around the player, adding, you know, other things to the scene so that when you spawn your character in, he has things like maybe a gun or some of the stuff. Number 6 is your event graph. It's where you're going to be placing your nodes and connecting your wires and your pins and all that stuff. So we'll be going over that here in just a second. So nodes, pins, and wires. Any questions about the blueprint editor layout before we move on? Just want to make sure that you guys are very aware of where everything is located before we move on. Okay. All right, so nodes, pins, and wires. So the white lines are your execution wires. It's basically your steps in your code. So think of the event begin play right here, or any event node or function node, or consider this your entry node where you come into the event or the function or the macro or something like that. And then whatever this white line is connected to is your step. So think of this as step 1, moving over to this node. And then this node is calling set and is passing in a value into this text field here that's going to set. But you can also use these pins right here. These are called data pins to connect up variables to pass data from the variable to this function. And this is a mutator, by the way. Anytime you see the set node, we're talking about mutators or setters. All right, moving on. So you can change the path of your execution. So things like branches allow you to split the path into two different directions. And it'll take one direction based off of the condition right here. All right, so whatever this condition is hooked up to, if you don't connect anything, there'll be a checkbox for you to check or uncheck. So you can do a manual transition between true and false if you wanted to. But most of the time you'll see it's something similar to this, where a Boolean is connected to the branch or some sort of Boolean operator, so like an and or an or conditional, like a greater than or less than, will be connected to the branch. And based on that value, it will determine whether it goes true or false. And you can do whatever you want. So just think of these nodes as replacing them with your code later on. Okay. So data wires. So let's look at what Unreal does when it goes from one node to the next. So like I said, entry node right here. So it's going to start right here, and there's nothing to do right here other than to move forward. So it's not going to do anything here. It's just going to move forward until it finds a node. And then once it finds a node, then it'll read the node. It'll be like, okay, so this energy variable is going to be set here, but it is connected to something. So let me read that. So it travels along and it reads this. It says, okay, I've got a multiplication node here. I've got a value, and then I have something else connected. So let me follow the path and read the value from here. Once I read the value, it pulls it in, does the multiplication, and then it calls the set, and then it moves on to the next node, whatever's connected to this output execution wire. Okay. Pretty easy stuff. So variables, let's talk about those. They're all bunch of different variables that you can add to any blueprint, and any variable type that you can pretty much think of right here. So Unreal or Epic Games knows that you're going to be using these variables more often than you're going to be using any other variables. That's why they're listed out up here, and they don't have a category like the rest of these categories down here. Typical Boolean, you should be familiar with Boolean, integer, float, and string at this point. Some vectors you should be pretty familiar with, but for the most part, you haven't been exposed to what a byte is, and we won't really be covering it in this class. Same with the name or the text. Just know that name, string, and text can be interchangeable. You can convert between those pretty easily. So just be aware of that. And then vector and rotator, these will fall into the transform. So there is a transform, or 3 vectors in the transform for location, rotation, and scale. But for the rotation, you can use a rotator. You set that whenever you need to. Under the structures category is any built-in Unreal structures, which is basically taking a few variables and putting it into a small container, and then you can use that structure instead of having to set each variable. You can go into and pull the structure in and use that to set the variables inside of the structure, and you can move the structure around. It's pretty easy. We won't be going in depth into structures here this month. Next month, however, you will be getting exposed to those, as well as enums. You'll be getting exposed to those. Interfaces and object types we will be covering in this course, and we will be covering those a little bit later. Interfaces, just be aware that all of your custom objects and structures, interfaces, enums, you'll find those in here. So you can add to these lists by creating custom objects of those types. Okay. So object types, like I said, if you remember that that diagram where object was up in the top left corner and then actor derived from it, well, every single actor that you create will fall under the object types drop-down list. And I'll show you those in just a few minutes. So details panel. So whenever you select a variable, you'll get this populated with information relating to that variable. So in this case, they selected an integer called player score, and then they can do things like set the default value down here. But there's some other things to be on the lookout for, some important stuff here in the details panel. The number one thing is instance editable. So when you check this, oops, excuse me, accidentally checked. When you check that, it's editable. What you're saying is that every instance of this variable, so whenever you create an object that owns this variable, that value will be unique to that object. So I could have 5 different objects that own this player score variable placed in the level, and if this is checked, then I can set any value I want, and it will be unique for each instance of that object. So instance editable. This also makes it public. So whenever you check this, you're basically saying that the variable is public and anybody can have access to it and modify it within the project. You can set a private flag here so that you can just turn it private. I think you can do both at the same time, so instance editable and private. We'll test that out today just to make sure. But that means that the variable won't be able to get accessed outside of the class. But being an instance editable would mean that each has their own private version of that variable. So just be aware of that stuff. Expose on spawn. So anytime you call a spawn actor node, which we will be doing for assignment 4, if you check that expose on spawn Boolean, basically what you're saying is when I call that spawn actor node, make sure this variable is attached to that node so that you can set that variable value when you create the object. And it's good for certain things like let's say projectile type or something else, that you want to set there, damage values or something specific. You can make a blueprint read-only, so be aware that there will be some read-only stuff that that we are going to be looking at later on in the course, but we will not be setting any variables read-only. You can set a tooltip, which is cool. Allows you to say something about the variable, what it's going to be used for whenever you hover over it in the event graph. Category, you can add a category so that it, instead of default value here, it would fall under a specific category like variable or whatever you want to put. It is completely user defined. So as you add them here, they will show up in the category dropdown anywhere else you want to put them. So if I add it to this blueprint and had a specific category for integers, anywhere else in the project, I can use that category if I wanted to. You can set ranges for sliders, obviously, and values so that you get a min and max for the value, meaning you can't go below the min, you can't go above the max. Bit mask is related to art, so you won't be messing with that. And replication is related to networking. And there are some extra features here on the dropdown, but those aren't as important as basically these four things over here, as well as that private Boolean flag. So once you set your variable type, you can change the container. So that little line there is a single instance of that integer. Array is multiple integers in a container. A set, I've never really used a set. It's an unordered collection of values. In my entire career, I've never used a set, but you may find a need for it someplace. So just be aware if you have to use a set, just be aware it exists, and you can do some research on it. We won't be covering it in this course. All right, a map is useful though. I have used that quite a bit, but we won't be covering it in this course. So if you would like to learn more about it, I highly recommend you look it up. Super useful. It's basically taking a key value pair. So a key being whatever you define. You define what the key is, you define what the value is as far as variable type goes. But just know that the key is used to access the value. Okay. And you can use the value to access the key, but for the most part, it will be the key is used to access the value. And then it says duplicate keys are not allowed. So that's kind of cool. Here's your getters and setters. So your getters are over here. This is what they look like in the event graph, as well as your setters. So accessing your variables here, reading the data, and then writing to your data or setting your data is over here. Okay. And now there are some pretty cool stuff that you can do with the Alt and Control key to get a get node. Use the Control key, and to create a set node, use the Alt key. All right, so let's look at some variables and nodes and wires and pins in Editor. So you should be familiar with the basic layout from your badges, so I won't be going over too much on this. Just know that by default, it'll look similar to this. You may not see that folder hierarchy view, but to get that, you just click on this Show or Hide Sources panel, and you'll get that folder view for you to browse your content browser. At any point in time, if you can't find a window or a tab or something like that, check this window drop down, because it may show up here for you to add to the blueprint or level, whatever this currently selected tab is. All right. Some other important stuff to note before we move on is editor preferences right here. So that anything relating to the editor that includes color of stuff, there is a content editor, I think it is. Somewhere in here, there is a way to change what the variable types are what they look like, colors for those. So just be aware that if you are colorblind, there is a place for you to change the colors of things so that you can see them a little bit better. But I wanted to point out right here in the editor preferences under appearance, right at the very top is the user interface stuff so that you can do some really cool things with this. I want to adjust this asset editor open location and make sure that I have the main window selected so that whenever I need to open up a blueprint or an asset, it'll just automatically add it to the this main window here. If you want to add a blueprint anywhere in the content browser, you just right click and you can select which blueprint you want. It's broken up into two different parts. So commonly used assets are going to be placed up here for you to quickly add. So Epic Games thinks that you're going to add blueprints pretty quickly, or levels or materials, so that they put them all up here under basic asset. But you can also find those down here in the advanced asset section. So blueprints right here, as you can see, blueprint class is listed right there at the very top under blueprints category, as well as here under the basic asset. So we will be creating a blueprint today. So I'm just going to go ahead and click on that, and then we'll see a pick parent class. This is the second step to creating a blueprint, determining what your parent class. So like I said, if you remember that object hierarchy, object is the base class, and then actor, everything else spawns or derives from actor. So the very top category is actor, allowing you to quickly add an actor to your scene. And this will be the most common one that you're going to be adding to your projects. And as you can see, as you hover over it, it's got a huge list of information for your tool, for the tooltip for that actor, and it explains what that actor is, as well as anytime you see that like U object or U actor or A actor, stuff like that, that's usually referring to the C++ backend code, and specifically their Unreal script. So what do I mean by C++ backend? Unreal Engine was made using C++, so the back end of Unreal Engine is C++. And what they use on the front end is blueprint scripting, so just be aware of that. So today we're going to create an actor, but there are multiple different types, and each one has a description of what it does. Plus, you can look at the documentation on that stuff by clicking these question marks over here on the right. I highly recommend you do that. And then down here is any of the other classes that don't fall under the common classes. You can search through and find. So if you wanted to, you can create something like a light. So we can do a point light as our parent class if we wanted to, and create a custom light. But we don't have to do that. So we're not going to be doing that. But you can find actor down here as well as anything that derives from actor in that drop-down category there. And most of the stuff is built into Unreal Engine, but you can specifically, anytime you add a blueprint to the project, it will fall in this category somewhere, and you can derive from that as well using this. So today we're going to create an actor, and we'll just call it BP for blueprint, and then underscore my new or my first blueprint. About that, my first. And then what I'm going to do is I'm going to save immediately. There's a couple of different options for me. Anytime I see that star symbol in the bottom left-hand corner of a blueprint, it lets me know that that object is ready to be saved. So we can do a couple things. We can do save current, which just saves the level blueprint. So anything I add to the level will, up here in the world outliner, will get saved if I hit that save button. And as you can see, that star is still there on the blueprint. So it's not, doesn't affect the content browser. So there's a couple of different ways we can do that. We can hit the save all button down here, which will save everything, including the level. we can hit File, and we can go to Save Current as, Save All Levels, Save All, or if you look to the right there, it says Control-Shift and S. That's my favorite. I use Control-Shift and S constantly. So if you see that little save bar pop up just randomly throughout the lecture, that's just me, the programmer, and me just hitting Control-Shift-S whenever I need to. All right, so let me show you that editor preferences. We have that set to main window. When I open up this blueprint now, it's going to open up at the main window. So if I turn that back to default and close out of that, and when I open up the blueprint, well, it opened up in the last location. So let me add another one and see what happens. Just add a quick one. Don't need to name it. Just open it up. And as you can see, it's got a whole brand new window. It is not docked to the other thing. But at any point in time, you can take these tabs and move them around, and you can dock them onto the main window if you wanted to, as well as you can dock them in other places, depending on what type of tab. So like this components tab, I can move around within the blueprint if I wanted to. And I can switch between components in my blueprint, but I'm not going to. So I'm just going to go ahead and delete that. I don't need it anymore. And we'll open up my first blueprint. And we'll set that back to main window. And then I'm going to hit Control-Shift-S just to make sure that I got everything saved. All right, so if you open up a blueprint and you happen to see just the details panel or the class defaults here, that means right now it's just a data only blueprint. It doesn't have any components or anything like that. So it just thinks you want to manipulate data. It doesn't think you want to adjust any events or anything like that. But you can open the full blueprint editor and it will look like what we saw in lecture. Okay, so let me move that back. All right, so let's add some variables. So first thing we're going to do is going to click this variable button, plus symbol right here. We're going to add a variable, and it'll highlight it for us, thinking that you want to rename it. So we'll just say my first bool. And then you'll see over here in the details panel that the variable name changed over here when I changed it over here. So I can change it at any point in time by selecting it and hitting the F2 key, and that'll allow me to rename. Or I can just come over here and rename it up here if I wanted to. Then we'll use this variable type to do the drop down, and you can just select any one you want. So just like an integer if you wanted to create an integer, but we named it my first bool, so we'll leave it a boolean. All right, and we'll drag it in here, get my first bool. And then I compiled, so I want to compile again, just to make sure that my default value category shows up. So whenever you create the variable, you don't get a default value for it, but you have to compile in order to get that. So let me show you something really cool about the compile button. Right next to the compile button, there's a drop down. And if you hit that drop down, it says save on compile. Make sure that you select the on success only, so that anytime that you successfully wrote some code, meaning that there are no errors in your code, anytime you hit that compile button, it will automatically save the blueprint for you. It's a good way to back up your work. So if you, without that, if you set that to never, then you can hit the compile button all day long, and none of your work will get saved until you hit that save button. So that's why it's always important to put save on compile on success only. If you set it to always, you will save errors into your blueprints, and you don't want to do that. So on success only. And then there's an option, a Boolean flag here, to jump to the error node. Anytime you compile, it'll automatically jump to wherever it throws an error. You can turn that on or off, but I don't have it on. There's no point for me. But for starting out, yeah, you could. That would definitely be useful. So you should probably check that. All right. Once you add the variable, you can drag it into the world, and you can determine or into the event graph, and you're going to determine which one you want to use. Get is this one right here, whereas set is this node right here. So very different. But you can also select the node. I think it's Alt and drag, and then Control and drag, and you'll get two different nodes instead of having to just use a context menu to determine which one you want. Yep. Okay. So data wires. So anytime that you need to connect two pins, you just click on the pin itself and you just pull off and drag somewhere, and wherever you put that, the mouse cursor is where it's going to connect to. If you can connect it, it's going to show up with like a green check under the mouse cursor. So you can just let go and it will automatically connect the two things. And it will allow you to do things like this, where you take the accessor version of the Boolean and connect it to the mutator version of the Boolean. But typically what it wants you to do is do some sort of operations associated with that. And if you're using it to initialize the variable, we don't need the accessor version, we just need the mutator version. And to initialize any of your variables, we're going to use this begin play event. This begin play event is, think of it as the start in Unity, or not your constructor, but think of it as the parameter list for, no, that wouldn't be a good way. It's just the entry point for the blueprint. So whenever you hit this play button up here, Unreal Engine calls begin play on any of the objects that are set in the level. Okay, so let me go ahead and add a breakpoint real quick. We're not exactly covering breakpoints just yet, but I just want to show you that any point in time you can go to a node and add a breakpoint, and that will basically pause the execution of the program. So right now I don't have the My First Blueprint placed in the level, so whenever I hit the play button, it's never going to trip up on that breakpoint. It's never going to stop on that breakpoint. But as soon as I drag that object into the level and then come over here and hit play, as you can see, as soon as that object is in the level, the level calls begin play on every single object in the level. So this will get run, or this will get run, and then you can use these step over, step into to do some debugging. But we'll go over debugging in a few days so that you guys get more exposure to that. Edward has a question. So it would be like the main slope as in the event begin play. Yep. Yeah. So this is a one-off, meaning that it will only get called one time, begin play, anytime that it is anytime the level loads and the object is placed in that level, it will call begin play. So you can transition from one level to the next, and that begin play will get called again on that object. Just think of this as a way to initialize this blueprint. So set any default values, run an initialize function, or something like that. Do a bind or something like that. You'll find out about all that stuff in a few days. Okay. What was I going to do? Let's check the lecture slides. Operators. Okay, so you do have access to a bunch of different operators. Arithmetic operators, plus, minus, multiply, division. There are some other ones like modulo or modulus that you learned in discrete math, and a few other ones as well. But for the most part, this is how you're going to be using them. So you're going to drag in your variable over here, in this case score, accessor or mutator, doesn't matter. And then you drag off in either direction from that data pin for the score, and you can hit the plus sign in the search bar, and it'll find what you're looking for. In this case, they're doing an integer plus an integer. but you can do other different things. So let me just show you that real quick. Let's create a new variable called my first integer. And then we'll set the type to integer and then compile and set its value to something like 5 or something like that. Okay. And then I'm going to use the control key, drag that in, get access to the integer. And then from here, I'm going to drag off and I'm going to do a search for the plus symbol. So it automatically with context sensitivity checked, it automatically knows what I'm looking for. So integer plus an integer, or a vector plus an integer, or an int point plus an integer, or this increment int. Increment int is a macro, but basically it's just taking the value of this and adding 1 to it. And then we could do things like a plus integer plus an integer if we wanted to, where we take, basically it takes the top value here and adds the bottom value. And then if we connect a variable to that pin, it'll read whatever the value is there and add whatever values in either this text box or whatever's connected to that data pin. At any point in time, you can right-click a data pin and promote it to a variable. So it automatically creates a variable of that type. So in this case, an integer. And it tries to name it, but it doesn't know what to name it. So it just says it new variable and then underscore the number of new variables you have. In this case, we'll say my second integer. And like I said, excuse me. Anytime we add a variable, we have to compile right away to set the value. So I think the other one was 25. We'll add 50 to it and see what we can do with that. And then this right here is an output pin, so you can use this to connect to another node. So if we wanted to set my first integer, we could connect it to that so that we're adding the two values together and then setting the first if we wanted to. Or we can at any point in time right-click in the event graph and use a print string. Think of print string like a way to display information to the screen that's not going to happen when you ship the game. So that development only is saying that anytime you're an editor, it will run this node, but if you're in a release version of the game, meaning that you're on a specific iOS device or Android device, you have actually shipped your game out, it will not run this print string node in that release version. So at any base variable type that you need to print to the screen, you can convert automatically to a string using this. This is a toString node. You should be familiar with that from C#, toString. So yeah, it just does that, converts it so that you can print it. You hit the drop-down arrow on the print string and you can change the color if you wanted to, so that it prints like red, and then duration is how long it stays on screen. So right now it's set to 2 seconds. We'll set that to 5 so that we can actually see it. So we got a value of 5 and then a value of 50. Let's add those together and see what happens. So like I said, the node or the object itself has to be placed into the world. And then once you place it in the world, it will execute code on it. And as you can see up there in the top left corner, we have that red 55. So it's nice to have this like sphere thing. So let's check out the viewport real quick, but I want to see something actually in the world. So let's add a component real quick so that you guys can see how to add components. So it's going to hit that drop down, and then like I said, there's a search components that comes with that add, which allows you to do search for specific. So if you were to, let's say, create a custom component, you could search for those if you wanted to, or you can use some of the default ones. And Epic is really good at putting the common stuff up, the top, the stuff that you're going to be using most often. So in this case, we're just going to draw a cube to the screen, and I'm going to drag it back up a little bit, drag it up a little bit, and set, I think it's 50 is the Z is where I want to. So now we can see that the cube is placed in the world. Had I set that, left that at 0, and compile and save, it's now you can see that it's like halfway through the world. So that little sphere is the origin of the object. So if you want it to be level with the ground, you want to put the sphere about halfway through the object. So if we look at the bottom of it, the top half is in the object, the bottom half is in the floor. So just remember that when you're creating creating objects and dealing with a default scene root. That's what that thing is called, is a default scene root. Now you can replace that at any point in time. I can just say that the cube is the default scene root, but I'm not going to in this case. I like to keep that in there so I can see that. And then with it halfway through the cube, as you can see, it's on the floor. Now, important things to note about placing objects in your level. At any point in time, you can move your object around and place it wherever you want. If it is hovering over the floor, you can hit the end key and it'll snap it where it's at in the Z. So Z is up. It'll snap it anywhere in its position X and Y, and then clamp the Z to the floor. So as you can see there, it's set the Z value to 20. And I can move X and Y in whatever direction I want. There is grid snapping, so as I move this, as you can see, it's a nice slow movement. But if I wanted to, I can change that to a snap, and so it'll move every 10 units. You can't really see that there. Well, let's use 100. Every 100 units, it snaps every 100 units. So you can adjust the snapping. One is super precise, so nice and smooth movement. You can place that pretty much anywhere you want. And basically what it's doing is just incrementing or decrementing whichever axis you have selected by 1 or by 100. Okay. All right. You can change the position using this handy dandy tool. To select that, use the select and translate tool here up at the top. And you can move that around anywhere you want. If you select the center of the tool, you should be able to move in all 3 axes. If you select the corner of 2 different axes, they'll highlight and you can move up or right, but I can't move back and forth through the scene. So yeah, just be aware of that. And then you hit the middle button, which is the rotate tool. So you can rotate in different axes, get some pretty weird behavior. Now it rotates around the origin. So as you can see there, the origin is the default scene root. It's rotating around that. If you wanted it to rotate from the center of the object, what you can do is just replace the default scene root with the object that you want to have rotated. And now when I rotate it, it's rotating around the center of the object. Very cool. All right. And then the last one is scale. Pretty self-explanatory. You can scale in multiple directions. You can scale all 3 directions at once. You can scale in 2 different directions. Yeah, very cool. Very cool thing for you to do. All right, so let's go ahead and delete this instance of the object and drag in a fresh one. Okay. All right, so think of, yeah, as you can see here, think of these as like prefabs. So whatever I set up in the blueprint, as far as the way it looks, think of it like a prefab. So if I wanted that cube or sphere to be, 100 units, away from the origin. When I go to the level, there it is, prefab. And I can drag that, drop that in, and then I can also come in, select the object, and over here in the details panel of that object, I can do things like select the specific sphere, and if I wanted to change that to like 500, and if we zoom out, as you can see, they're instance editable for setting those objects up, and then if I drag in a new one, it's not the one with the offset 500, it's the one based off of this viewport and how I set this viewport up. Okay, so back to lecture. I think that's pretty cool. Started off with addition and started doing some, went off on a tangent, so apologize on that. There are relational operators, less than, greater than, equal to, less than or equal to, greater than, equal to, not equal to's. So you do have relational operators available to you. This is typically how they're used, comparing two values, and then typically with a branch to determine if I should set that value or not, or execute some code or execute this code based on that. Right? Logical operators, another type of conditional operator where it checks the value, and based on those, it returns a Boolean. So in this case, it's taking in two bools and ANDing them together. So if this value is true and this value is true, this returns true. If either one of them is false, this returns false. If they're both false, it returns false. Or is the opposite. It says if either one of these is true, then this will return true. If they're both true, it will return true. If they're both false, it will return false. And then not operator just takes in a Boolean and returns the opposite value. So if the Boolean coming in is true, it returns false. And if it's false, it returns true. And typically you'll see those connected with branches to determine the path or the flow of the execution. All right. I'm not going to cover all those operators and their uses in example. I would like for you guys to do that on your own time. Just drag in each one of those nodes, connect it up to either a print string, a branch, or something else. In fact, let me show you examples of what you should do. So if you wanted to test some stuff out, what I would do is just at any point in time bring in a branch. So to do that, I can search for branch, right, and find that. Or I can hold the B key and left click, and anywhere I click, branch will show up. Also, if you search and type if, a branch will be selected as well. So think of these as your if statements. The question that you're asking is the condition, and the code that you run is the body for true, else, false, right? Okay, so if you wanted to test out some conditional operators, what I highly recommend you do is just do a couple of print strings connected to the bool and just say, oops, true, and then you can copy any node at any point in time. So you select it, Control C, Control V, or you right click and do a copy and right click. Don't think it's going to let me paste, no, but you can Control V. All right, so yeah. So this is how I would set up your, so if you want to test those Boolean operators, logical operators, I would just set up something like this and just change this to false. And then print it to the screen so that you can test those on your own and see how those things work out. All right, so moving on, functions, events, and macros. So functions allow a set of actions to be executed in various parts of your blueprint. Basically, you put a bunch of nodes together and you can collapse it to a function, or you can just create a new function and add a whole bunch of nodes in the function. It's just like a bundling of nodes for you to do to execute some code on, right? And you give it a unique name, so a function name, a return type. You give it parameter list, just like regular functions. And this is what it looks like. So instead of parameter list, they say inputs, okay? So they'll show up here on the entry node. So anytime you add an input, it'll show up here. Anytime you add an output, it'll show up on the return node, so as your return type. Okay. Now you can have multiple inputs and multiple outputs per function. So this is the one thing Blueprints does that regular code does not, is that you can add a bunch of different variables to the return node. Typically in regular C++ or C#, you can only have one return type, but what you can do is return a structure in C++ or C#, and that's pretty much what Unreal is doing here, is returning a structure instead of each individual variable. But that's just behind the scenes stuff. Just keep that in mind. Local variables. So this is that local variables category I was talking about. So when you are in a function, selected a function, and you're actually editing it in the blueprint or event graph, this category will show up and allow you to add local variables. Local variables only exist within the lifetime of the function. So when the function enters, it gets created, and then it exists for the lifetime of the function. And then when the function exits, then it falls out of scope and no longer exists. All right, so let's talk about targets before we go in and show some examples of some functions. Target here is referring to this data pin. Each function will have a target, meaning who owns the function. So in this case, who's invoking the function, not who owns it. So I can pull in this destroy actor node from any blueprint, and based on the target determines who calls this destroy actor. If the target is set to self, that means that the owner of this event graph, excuse me, I clicked. The owner of this event graph will get destroyed. So that's what self is. Whereas the target here, where it's connected to other actor, it's whatever this actor is. So in this case, we collided with something. So there's a begin overlap getting called. So the object that I collided with, not myself, the object I collided with will be the one that gets destroyed. And then in this case, we're using a variable for an object reference, and we're targeting that specific object and destroying that. So let me show you what I mean by target, and I'll show you the destroy actor node as well, and we'll show you some functions as well. And then come back and learn about events. So at any point in time you want to add a function, you have two options here. So if you hover over the functions category, you have an override option as well as a plus function. So if your parent owns a function that you want to change the behavior on, you would call this override. So there are some built-in ones for actor, and then yours will show up with the name of the specific class over here on the right side. But we're just going to add a function, and we're going to call it my new function. This is my unique name. So if I wanted to change that name at any point in time, I can just single click over here in the functions category. I can hit the F2 key. I can select this node, the entry node, and up here in the details panel, I can change it. But if I don't have that entry node selected, but I have this over here selected, it doesn't think I want to change the name, so it doesn't give me that option. So select the entry node in order to change the name. You can also select the entry node and hit the F2 key, and you can change the node or change the name of the node there. So we can add a description, which just gives a short message describing the purpose of the function. If we wanted to, we can change the category. So let's say it's in the So watch over here as I add this category. I'm going to say, we'll just say a functions category. No, that's already there. Let's do custom functions. How about that? And as you can see over here, custom function showed up. And if I hit the drop down, my function shows up under that custom function. Same thing works for the variables too. So if I wanted to change the category, I could say custom variables, and it'll show up down there. So, yeah, okay. Back to functions. Access level, I can change it from public, protected, and private if I wanted to. We'll leave it public. Keywords I don't really mess with, but you can use it, I'm assuming, with conjunction with the find blueprint. Pure functions, let me create a second function real quick. So I'm just going to select that, and I can duplicate that function, and then we'll just say my pure function. And then we'll set that up in just a second, but I want to make sure that we cover everything. So, new function, we're going to add some inputs. So I can add whatever type I want. So integer, I can name that int or some data related integer, life, whatever I wanted to add there. And I can add, like I said, a whole bunch. And then I can oops. And then I can remove stuff by hitting this X. So I got life, death in between. I can, like I said, reorder that. So life in between death. Yep. And then I can add outputs. And as I add outputs, return node will show up automatically. I can change that to a Boolean. Did run. And then if I wanted to, I can connect stuff up in between the nodes. So something like a print string if I wanted to. And then I could even do some other cool stuff, like set that to my new function entered. Right, print that to the screen. So just think of this print string as replacing that with any of your custom code. So if you wanted to do some addition, subtraction, call other functions, just think of custom code. Anywhere I use print string in my examples, you can replace with custom code. All right, so this is a regular functions, not pure. This is what you would typically see. You're adding inputs, you're adding outputs, you're adding nodes in between to execute. And then anytime that you do add nodes, make sure you always compile. Now let's check out the pure function. Pure function, we're going to do one single output, and we'll set it to an integer, and we'll say my first integer, and we'll just get my first integer and we'll pass it through. And then we're going to make sure we check that pure and compile. And then when we go to the event graph, I'll show you the difference between the two. So to get it to execute a function, you're just going to simply drag it into the scene and then connect it up. Or what you could do is drag off of an execution wire and search for my new function. And as you can see right here, it's under our category, custom functions. So our categories show up in our search bar. And if I use the output node of the previous node as my search, it will automatically connect it for me. So as you can see, they're automatically connected, but if I didn't use that and just search, and we use that, it doesn't connect it to anything. So just be aware of that. At any point in time, you can disconnect execution wires by holding the Alt and clicking on a pin. So that includes data pins. But you can also, if you wanted to move an execution pin, hold the control key, and now you can move that connection. Just be aware of that as well. Let me show you the pure function. The pure function is going to look quite different than this, this function. You'll notice that every single function that we've added has this blue bar at the top, including our print string function here. But with the pure functions, we get a green bar. And basically what this is allows you to, let's say, not have an execution wire connect to this function to run it. The way it gets ran is through the data wire and its connection. So when my new function gets entered, it sees that something's connected, and then it comes in and reads the value of whatever the return type is. But really what it's doing is executing that code. So I could do some pretty crazy stuff like other print string here. I know it's crazy, right? Print string. But like I said, just replace this with actual code. And we'll say pure function ran. All right, so now when I run the code, you'll see it prints all that stuff. Pure function was ran. And if I stop, my new function, did that not run? Oh, my new function, yeah, it's right there. It just disappeared real quick. We didn't adjust the time. So there you go. Printing our number out, the pure function ran, and then the my new function ran. So let's look at that from our event graph. So here's our print function for that 55 we were printing, but then it said that my pure function ran before my new function ran. So just be aware that that when you got things connected, if there are pure functions here, they're going to execute before the node. Okay. All right. So any questions about functions, adding a function, adding inputs, adding outputs, setting the access level? Oh yeah, I did want to check the private. Okay, so let's take my first integer here, and let's set that to private. And then let me show you the level blueprint. So we're going to do a little bit of blueprint communication here a little bit early. But if I wanted to get access to an object, I can, at any point in time, I can select that object. So we'll select this, my first blueprint here, and go to the test level. So I went to blueprints drop down here, and I selected the open level blueprint. And that brought me to this test level, which is the name of the level, but this is the blueprint version of the level instead of the viewport version of the level. Okay. So I can then, once that object is selected, I can right click into the scene, and as you can see up here at the top, there is a create a reference to my first blueprint. And this is an object reference. It's directly connecting, or it's directly taking this blueprint reference and placing it into the level, and I can do things like call functions on it. So like my new function, if I wanted to, I can run that function. I can do that pure function, my pure function. I can call that, and there's that target we're talking about. Because this function lives inside of this blueprint, that target is I'm using that to find the blueprint. Okay, we'll get to the target stuff here in just a second, but I want to look and see if I can access my first integer. Okay, I believe that's the name of it. Let's look, my first integer, yep. So when I search for my first integer here, oops, got mount. Integer, it doesn't show up. If I turn off context sensitivity, it still doesn't show up. Okay, so that's important to note. And then if I hit uncheck the private and compile and save, if I drag off and search for my first integer, turn on the context sensitivity, disappears. My first integer, no. Yeah, if I turn it off, it shows up. For some reason, it wasn't showing up the other way. Strange. So yeah, that's how private works for your variables. So you just check and uncheck that to change that behavior to basically, can I access that outside of my class? And this is the level blueprint, and we are outside of the class. I'm using a direct reference here, but I can access that outside of the class. And when it was private, I could not. So just be aware of that. Let me just go back real quick and just take a look and see if I've covered absolutely everything. Did our operators, told you guys to do that for fun. We added some functions, we added some inputs, we added some outputs. Local variables. So let's go over that. So you saw me add variables, and here, let me show you that I cannot go any lower in the My Blueprints panel. There is nothing past event dispatchers. And even if I try to expand the window even further, shorten that, as you can see, there's nothing below event dispatchers. But as soon as I go into a function, that local variable shows up and allows me to add variables. So let's do my first local variable, right? And then I can do stuff like access it, I can mutate it, set, access set, or get set if I wanted to. But if I go outside of the function, right here, and I search for my first local variable, it doesn't show up. And I uncheck my context sensitivity, still doesn't show up. Now, if I wanted that to return, what I can do is I can't return the actual object. So, but if I wanted to return the value, I can, at any point in time, you can take a data pin and drop it onto the return node. And if I select the function, it'll automatically add that return type for me. So right now the value is set to 0. So let's set it to something ridiculous like 15,000, right? And then go to our event graph, and what we can do is print. So copy, paste. And connect that up. It will do the 2-string conversion for us. And I want to change the color so it's not one of those. We'll do a nice bright purple. We'll set 5. So run the game. So 15,000 shows up. So the value can be passed out of a function, but the variable itself cannot. And then if I were to place a breakpoint here and run it, now look at the value, it's still there. It will be there until I exit this function or this event, begin play here. So once I exit, fall out of scope there, the way to do that is I can add, here, let me add another print string here. I'm not actually going to print anything. I just need a node there so that I can add a breakpoint. Okay. So if I hit play now, you see that we got the value still there, 1500. I hit resume. It's going to hit that print string on my tick event. I go back and look at it. Well, Unreal is reading it. So, still executing that. Let's do a frame skip. Yeah, let's set this to 10. How about that? 10 seconds, and we'll set this to 1 second. So hit play, then we'll hit resume, and resume. Okay, now it should have fallen out of scope, but we can still read it. Strange. Maybe that's just the simulation. It expects me to like hover over stuff, so it's keeping the values there in local cache. Not entirely sure there, but it should have most definitely fallen out of scope. Yeah, we'll figure that out later. Anyways, moving on. Let's look at events. Oh, yeah, the destroyed actor. Yeah, let's do that instead. Targeting our destroyed actor. So if I wanted to, at the very beginning of begin play, we'll call destroy actor. All right. So right now, we are going to leave this targeting self, okay? And I'm going to go to my test level so you can see I've got all three of those my first blueprints in the test level there. If I hit play, oops, got to remove the breakpoints. And resume. Now if I look, it executed all the beginning play code, but it destroyed all the actors, okay? So just be aware that when you're dealing with a destroyed actor node, you can execute code after you call it. And Unreal will totally do that. However, you're not guaranteed, if you're referencing this specific object self here, you're not guaranteed that it's going to be non-corrupted data, is what I'm thinking of there. All right, so let's look at the target. So right now we're targeting self. If I were to, let's say, add a new variable, and we're going to add, we'll just say target here. And then we'll add a object type, and we'll do actor, and we'll select, let me show you that again, actor over here, and I'm going to select object reference. You can do other things, but I just want to select object reference there, and then compile. Once I compile, you'll see that I now have a target. We'll check this instance editable as well, so that each of those objects has their own unique one. And I'm going to select, this front object here, and down here under the default details panel, I can set the target. And what I'm going to do is I'm going to use this eyedropper here so that I can select a target in the level. And once I do, it as you can see here, it's BP_my first blueprint. It's the same name as that object that I selected in the level. So with that selected, now I can go to my first blueprint and drag in my target here and connect that to my destroy actor. All right, Control-Shift-S, save, and now when I hit play, I want to show you something else with the play button here. If I hit this drop down next to the play button, I can set my camera from spawn the player at my current camera location. The player start, as you can see here, that object is where I was spawning before, right? And it's, I'm now going to be spawning right here where I can see all three of these objects looking down. So hit the play button, and as you can see, that object disappeared, and the other two objects are still in the scene. So target matters, right? So if by targeting self, each one of those objects, because they are each my blueprint, my first blueprint object, was destroying itself and disappearing. Now, when I set a variable called target, I can name that anything else. Let's see, let's do that. Let's name it my first target. Oops, caps lock. Just so you don't get confused, this is the name of the variable. It's not the actual target that the functions are looking for. It's just a variable was set to this object here, right? And because it's connected to this destroy actor, I am specifically telling that object to destroy itself. Okay. And we can use it from a passed in function. So let's go ahead and hook that up. We'll go ahead and move this past the node. I'm just going to leave that connected, and I'm going to copy it. Because the entry execution wire is not connected, it's the same thing as me commenting out that code. So just be aware of that. And I'm going to move that over here and oops, connect that up. Then I'm going to go inside this function and I'm going to drag in my first target here. I'm going to pass it through the function and connect it up this way. Okay. All right. And as you can see, that third object is gone. It is destroyed. So same exact behavior. We can pass the object through a function if we wanted to. We could even do it based on collision if we wanted to. So destroy actor, copy that. So if that object, this blueprint object collides with anything whatsoever, what I'll do is I'll just place a cube over the object here, and we'll turn physics on for that. Simulate physics. And we'll make sure that I've got the collision settings set up correctly. Physics actor, it should work, maybe. No, I'm gonna change that to overlap all so that we actually do run that begin overlap event. All right, so when I hit play from here, strange. Let's look at the cube. Select that, and no, it did not destroy. Add a breakpoint. Is it not colliding? Is that what the problem is? Well, they are overlapping. All right, so this is where the debug filter comes in handy, right? I'm just gonna set no debug filter object selected, and then it's not executing that. So that makes me think that there's something wrong with the collision settings on this object. So let me go and look. There it is, see that? Generate overlap events. Let's look at our cube, specifically our cube here. Go to our simulation generates hit events. Generate overlap events is checked. Block all dynamic. overlap all dynamic. Let's try that. No, it's not running. Okay. Something must be wrong with my code. There are some errors. Let's take a look. Access none, trying to read. Ah, that's why. Okay, duh. The actor was destroyed already, maybe? Let's just make sure I'm doing this right. No. Is it even entering the node? What is the name of that object? 2. Let's try that. Turn on hit events as well. See if we can get something going. Nope. Okay. Strange. Let's do a specific custom function. We'll do on component begin overlap here, and then we'll use that in conjunction with our destroy actor. And see if that works. File, save, play. Nope. No. All right. Well, I can't get that to work for some reason. I'll have to look at it later and let you guys know. Events, custom events. Yeah, it's really weird. I thought I was setting everything up correctly. It must be, what I'm thinking it is there's a difference between the save file and the cache file, and like the cache file is saying you've got something connected and those are checked, and then the save file is saying something different and it doesn't know which one to use. So anyways, let's look at custom events and adding events. So at any point in time, you can right click in the blueprint and search for add custom event, and you can do that, or search for an event and the add custom event will show up. Custom events are similar to your functions and stuff you can add. You can add inputs. However, events differ from functions as in that they don't have any outputs. So you can't do a return node on an event. Only inputs, so only passing in information into it. This is an append node. We'll look at that later, not today. The cool thing you can do with events is delegates. So you're basically connecting two nodes together. So this is a set timer by event node. It's a way to create a timer if you wanted to. So when this begin play node gets called, it sets up this event or this function to a looping event. So every second, it's going to call this, oops, thinking I'm in the event graph. Every second it's going to call this custom event here and run this code. Okay, that's basically what this node is telling it to do. And anything connected to this event input is the thing that gets called based on whatever the rest of the nodes set up. So just be aware that you can connect two nodes together. This is basically binding the two together. So just remember bind when you think of delegates and set timers. All right, so let's look at functions or events. Excuse me, keep confusing myself. So at any point in time, I can add a custom event, and I can name that whatever I want. My first event. Right, and I can add inputs, do whatever type I want. I can name them, and it'll change the name. To show you, blarg, right? Instead of bool. Yep. And then we can do things like there's a call and editor, which if you select it and you hit this call and editor, when I go to select that object, scroll up in the details panel. Come on. It is not working with me today. Let's search for that my custom event. Yeah, I don't know why Unreal's not working with me today. But trust me, if you're starting from a fresh project that doesn't have any errors, background errors, I don't know why my project's not working, but you select that call and editor, it'll show up in the details panel over here of that object in the level and allows you to click it. I've done it quite a few times on my other projects. Same with functions, you can do that with functions. So if I come over here and select a function, I can select the call and editor and it will run that function every time I click that button in the editor. Replication, again, this is networking stuff. You don't need to worry about that. You don't need to worry about deprecated. You can add keywords if you wanted to, but you'll notice there's no category here. So it won't show up in a different category. It all shows up under the event graph here. Okay. The way it works is it just shows up in your event graph and you just connect things to it just like any other function. To call it, you can right click and say my first event, and it'll allow you to call that function version of the event. So when I connect this up to my begin play up here, I'll just connect it up over here. We'll add a print string down here, just so that we can see it on the screen, and change that color to like a lime green. The event was called, and change the time to 5 seconds. So event was called. So as you can see, you can call it anywhere. Call it yourself, and then you can even call it outside of blueprints. So let's go up here and my first event. So it's only the one time because I removed the other print string, but here, but I am calling it and it is running that specific event. All right, so that's events in a nutshell. Let's look at macros. Macros are similar to functions and events where you can have inputs, you can have outputs, but the cool thing about macros is that you can have multiple execution wires come in as well as multiple execution wires go out. So let's talk about the difference between the three. So macros, custom events, and functions are pretty much similar, but the main difference is that macros have output parameters and can have many execution paths. Right, so that the execution wire can go in from multiple different directions as well as out in multiple different directions. They cannot, however, be called from another blueprint. So if a macro, think of a macro as like a local function as opposed to a local variable. However, I will say this, you can create a macro library, and with that macro library, you can call macros from other blueprints. So just be aware of that. Events do not have output parameters. They only have input parameters. And they can be called from other blueprints and have a delegate reference, which means we can connect two nodes together. And every time that one node gets called, the event will run. They do support timelines. So timelines are what we call latent action. It's messing with time. Same with delay. And then functions can be called from other blueprints and have output parameters as well as input parameters. They do not support latent actions like delay and they cannot have multiple execution paths. So let's take a look at that. So let's add a macro. I'll call this my first macro. And we can add inputs. So we'll add a couple. At 3, we'll add 3 outputs as well. We'll just say first one will be exec, and then we'll change that to execution wire. And then we'll do the second one, we'll do exec, oops, out, exec. How about that? It doesn't like the fact that they're both named the same thing. And we'll set that to exec. We'll just connect those two up directly. Well, actually, you know what? I'm going to do something cool. Take this branch, and we'll change output to set that to true. And then this one to false. And then this one to exec. And then connect to 2. And then we'll remove a parameter, and we'll say, oops, come on. Thank you. It was off screen, so it was an issue or something like that. We'll take in an integer, and then we'll do a conditional operation. We'll say integer greater than 0. If it's greater than 0, return that, and then in fact we'll change our, just remove that altogether, and we'll pass the integer out. I want to show you a reroute node. So a reroute node is basically a way for data wires to change direction. So if I double click, hover over any wire, and I double click, I get a reroute node. It allows me to basically move that wire. I can do multiple ones as well. So I can get some nice straight lines with my data wires if I wanted to, so that I can organize my code a little bit better. So we can see exactly how things are working, right? Let's see here. Another cool thing I want to do, want to show you is at any point in time you can comment code. So I'm highlighting all of these nodes to comment all of them, but I can, if I delete the comment and just select these 2 nodes or 3 nodes there and comment those, it'll just comment that. And I can change whatever the comment is. Return, right? And then with it selected, I can then move all 3 of those objects in that comment if I wanted to. Now you can change that behavior from group movement to comment movement. So I can just move the comment around if I wanted to, and then change it back to group, and now it changes that behavior. Another cool thing you can do with comments is you can change the color. 16 million colors or whatever, completely available to you there. And font size as well, make it bigger. Very cool. All right, so macro, let's see. Go to our event graph and let's drag in our macro and see what that looks like. So as you can see, we've got an exec coming in and a true false coming out, right? So let's actually use this in our tick event. And we'll say if it's true, we're going to come over here and we're going to print out value, and then we'll use bright green there so we can easily see it. And then 5 seconds is plenty. And we'll say, I think, what was the macro checking? If we're greater than 0. So we'll just set that to 1 now, and then if it's false, we'll destroy the actor. Okay, so it does print out to the screen. Now, the one thing I want to note about the tick event is this runs every frame. So every frame for 5 seconds, it is printing that value to the screen. So let's drop that down to 1 second so that you can see how many frames get executed in 1 second. Okay. Let's look at that. So as you can see here, there are so many frames getting executed in 1 second that it goes off screen. And in fact, I can't adjust it any further. So let's change that to like 0.5. So half a second. How many frames are getting run in half a second? Again, it goes off the screen. Okay, let's do 0.25. So in a quarter of a second, how many frames are running? All right, 1, 2, 3, 4, 5, 6, 7. Yeah, so it depends on what you're doing in the scene. So if I move around a whole bunch, you'll see some frame drop. Yeah, so yeah, that's the tick event. So it gets run every frame. There's a way to set it up so that you can do this time-based, but that's fine. I can run it every frame. All right, and then if we hit 0 on there, or, well, it's not greater than 0, so let's see if that'll work. Yeah, and as you can see, it just deleted all 3 objects and it's not running that event anymore. So macros are super useful. Very cool stuff that you can do with it. Let me show you, okay, we're pretty much done with lecture for today. So let me show you a project that actually uses pretty much all that stuff in action. So a real world project and what a real world project looks like with code all connected, and what functions will look like, what you typically would see in a game. Just a second for that to load. Got to build all the shaders and all that stuff, so it just takes a second. All right, so let me just play the game real quick so you can see what it looks like. It's just a simple node-based game where you highlight 4 nodes that are connected, and once you connect the 4, it transitions to the next level. All right, so pretty simple game. The 4 of the same color connected, it goes to the next level. So let's look at the grid here. The grid is that cube system with all the different colors, and this is the create grid function. So in this function, I have multiple different functions as well. So I got a clear grid, which goes through the grid and just clears out all the data. Got initialize grid, which we're looping through every single grid object, and we're spawning a cube at that location, and we're attaching that component to the origin. Doing some stuff, simple stuff in the background. We do this build grid function, which uses all kinds of different nodes. We're using a sequence node here, which you'll see in a few days. Basically, what a sequence node does is it takes an execution in, and then it runs each sequence in order. So this top one gets run first, then it runs a second, and third and fourth, and so on and so forth. And each of those is connected to a custom function executing some code. So as you can see here, I'm just doing some default value there, selection, create grid. That's the cube. We're in the grid. And then this one is like setting location data. All I'm doing is just calling a bunch of functions there. Back to that. Generate grid pattern. This is where I do the polling of the different colors, and we have the unique colors. So if I look at that function, as you can see, completely zoomed out, it takes up the entire screen. So let's look at that and see what it's doing. So we're going to loop for an array of our transitions. So we're resetting all of our transition stuff. We're setting our color, so the wind color, and this is a, I believe it's an enum. So I determine what the enum is, and based on options there. We're doing some random stuff. Moving through, we're choosing the adjacent winning tiles here, so we're looping through those. So that's a quick loop body for that. And then once that's all done, picking the adjacent tiles, it comes down, does some color looping and selecting some colors. And this here looks really weird. So if the unused tile length is greater than 0, it comes back and breaks the loop and moves on after that. Some more recursive functions here. So anytime it loops back on itself, think of this as recursion. You could potentially get infinite loops unless you have ways to break out of the loop. Okay, so that's why I have stuff connected to that break there. Yep. So yeah, that's pretty much actual code for an actual game, doing actual stuff. As you can see, it can get pretty complicated, but that's just one function, this generate grid pattern, that exists in the create grid function. So yeah, so that's it. Any questions, comments, concerns about Unreal Engine or what we covered in lecture today? Was everything pretty well covered? You guys understand everything that I covered today? Got a green check mark from Max. Okay, so I'm just going to go ahead and stop the recording here.